This is the new streaming meta right here, where you come to YouTube to watch a Twitch streamer who's watching a YouTube video. I love this. This is great. Oh my god.
The internet is a wild place.
It really is.
What's up, everyone in YouTube land? We are doing Advent of Code Day 10, and we are racing the famous Bad Cop, and we're going to try to do it faster than she does it. We're going to be doing it in Bash, and yeah. So let's see her startup script. Listen, it could be totally useful to use it, but I'm not going to change the way I do things now. Speed is the name of the game here, so we're going to go as fast as we possibly can. Oh my god, Day 10 is named Hoof. How perfect for this. You'll arrive at the lava production. I don't know if I can read through all this. The goal is to be fast, right? Right? We might just have to cruise through this one. Sorry, it's going to be a little bit different than how we do things, but we're just trying things out. The topographic map indicates height at each position using a scale from 0 to lowest and 9 to highest. For example, okay, so 0 is the lowest and 9 is the highest. 0, 1, 2, 3, 1, 2, cool. Based on unscored scraps of the book, you determine that a good hiking trail is as long as possible and has an even, gradual uphill slope. Okay, for all practical purposes, this means that the hiking trail is any path that starts at 0, ends at 9, and always increases by a height of exactly 1 at each step. Oh, okay, so it just counts from 0 to 9. Easy. Hiking trails never include diagonal steps, only up, down, left, right, from the perspective of the map. Okay, getting easier. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, whatever. A trailhead is any position that starts one or more hiking trails here. These positions will always have a height of 0. Assembling more fragments of pages, you establish that a trailhead score is the number of 9 height positions reachable from the trailhead via a hiking trail. Okay. This trailhead has a score of 2. So a trailhead starts at 0. This is where we start a trail. And we can go 1, 2, 3, 4, 5, 6, 7. We can go down the left side or we can go down the right side. So there are 2 possible paths from this 0 to get to 9, increasing by 1 every time. So because there's 2 possible paths from the 0, this trailhead at this location has a score of 0. This makes perfect sense. Oh my god. Oh my god, please be this easy. The positions marked by period are impassable tiles. To simplify these examples, they do not appear in your actual topographic map. This trailhead has a score of 4 because every 9 is reachable via a hiking trail except the one immediately to the left of the trailhead. Okay, so this is the trailhead. We can't go to left, but we can go to 4 different locations of 9. Okay, that makes sense so far. The topographic map contains 2 trailheads. The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. So this one has a score of 2 because it can go up. Oh, okay, that makes sense. And it can go down here, whereas the trailhead at the top, oh, there's a 0 here. 0, 1, 2, 3, 4, 5, 6, 7. It can go down. Okay, cool. This makes sense. So here's a larger example. Okay, so we have to go through, find the zeros, and then from the zeros, we have to check all the cardinal directions and see if we can count up by 1 until we hit a 9. Every time we can, that location at 0 gets a score. This larger example is 9 trailheads. Considering the trailheads in reading order, they have scores of 5, 6, blah, blah, blah. Adding these scores together, the sum of the scores of all trailheads is 36. Oh, this is cool. So each individual one has a score, but we only need the final score, which is a sum. So technically, we can keep track of just any score. We don't need to keep track of which trailhead had the score. That's cool to know. All right, so what we'll do is we will, oh my god, I have so many windows open. You have no idea what I had to do to get this stream working, but it was so worth it. When she was like, she wanted to collab, I was like, absolutely. I'm so down for collabs. So here's where we have our Advent of Code terminal here, make dir day 10, cd into that. Now we're in 10. Let's grab the example input.text, not text with an I. And here is our example. I'm copying and pasting this from the Safari window. Sorry, I will do my best to try and read chat, but I may have to skim through it just a little bit because I'm in a race, guys. And I am not the fastest program. I don't know. I mean, if you've watched me stream, you know this. I'm going to turn this off while I pull the real input in. If you've watched my streams, you know that I am not the fastest at programming. I'm just incredibly thorough and like to make sure I do it right, so it will always be right. That's just my preference. Cool. So now let's start working. So we'll vim part 1. Let's see what we should be doing. So we have this example output. So we need to create basically like a 2D, two-dimensional array of all of them, which we have done before. So we will declare a matrix, and this will be an XY coordinate of each thing. So while read -r line do done, that will read them from standard Yeah, that will read in from standard in. Cool. So we need a height
Did you like send a bunch
and
of
a width.
saboteurs over here? Because
What?
they are.
No, wait,
I'm
seriously?
getting. No. But I'm getting. I think my chat just doesn't want me to win.
Oh no, hold on, I'm pulling up your stream. What's
I
going
have
on here?
redeems that let them like interrupt me, and normally they don't use them that much. But suddenly they're very
No.
interested in them.
Oh no, I did not send anyone over. I didn't.
No, I
Um,
think it's my own people.
but now you're giving me ideas. I did make a story about this on Instagram to let people know that I've been doing this live. But yeah,
How
guys,
have you finished or have you like started writing any code yet?
I have a while read line.
Oh
So
God, he's so far ahead of us.
I have a while read line. That is it. I pulled up your stream right just now. What is happening on your stream? Why did all that text just fall?
Yeah, that's chat really. They have too much control.
Bad cop, what happens on your streams? I need to actually start watching
Yeah,
your streams.
you should see the hot dog redeem that they did as well.
Oh no.
And
Oh my god. Okay, for anyone in my chat, go check out Bad Cop stream just because they're hilarious. Don't sabotage her. I mean, unless you want to. But this is great. Oh my god.
see, this is the type of sabotaging I can get behind. Gifting me subs, you can do that. That's fine. Keep doing that.
Yes.
He doesn't even stream on Twitch.
I'm learning. I'm learning. I'll get there. I'll get there. But no, she's hilarious. It's so fun. I'm glad she literally reached out to me. She emailed me and she literally just said like, "Hey, I like Bash," and I was like, "Cool, let me check out your stuff." And I was like, "Oh, this is awesome." This person's as crazy about Bash as I am, which I didn't know was possible. So the height gets plus plus when we read in one line, and the width is equal to the length of the line. This is fun. I'm glad you think it's fun. I think it's like super fun. How does her audio sound when she talks? Does it sound like good? Is everything good? Does my audio sound good? I'm so paranoid about this stuff, so I know I'm just gonna keep asking. What's up with the audio? You sound like you're in an aquarium. I was just asking about that. Does it sound bad?
How does this sound? Does this sound way better? OBS decided to use my default input device, which I'm wearing AirPods today because that allows me to hear her when she's talking through Discord. So I just changed it over to the Yeti mic. So now this is the mic. Does it sound way better? Probably sounds so much better. Sorry about that. Yes, feel free if the audio sounds bad to just let me know. Because yeah, I don't have any real-time monitoring of this, so I can't tell. Cool, awesome. Yeah, thank you everyone. I appreciate that. All right, so now we have this and we have this. So the width and the height is the X location of it and the height is the Y location. So we can say, let's grab the char at that location. We have to loop over every character, don't we? Yeah. For I equals 0, I less than width, I plus plus. Done. Let's not make that I. Let's make that X, so we're consistent. And then we will do matrix key equals X comma height. We will do matrix key equals char. We don't have char yet. Let's define char as whatever is in line, the variable line at position X, one character. So we're just going to substring it. That's all we're going to do. We've written this logic before. So now if we were to like print out this matrix, it should work. Yeah, I'm going to pull in that print array command that I use from day 9. So now in our part 1, we can just source print array PRR, and we can just print array matrix. My audio sounds way, way, way better. Thank you all. Appreciate it. Yeah, feel free to let me know if things sound bad. Usually I just have no idea. Oh my god, chmod plus X, part 1. I'm like nervous. I like want to win this race. Alright, cool. Does this look good? Now let's find where 0, 0 is. 0, 0 is 8, so the first top left character should be 8. Cool, yeah, that looks right. Let's just assume I did it right. Damn, I'd have at least 3 echoes by now. Bruh, listen. We can't all be Bryans when it comes to programming. Oh man, I need to get like YouTube chat on my stream. I think that'd be fun, more engaging. especially during the VODs. So what do we have here? We know where all these things are. So now we need to, we read the data into matrix. Now we need to iterate or loop all the data looking for trail heads. Johnny. A bad cop, just so you know, someone in my chat just said we're sabotaging bad cop. I did not send them there, but they just said that in my chat, and I feel like I should let you know. I'm gonna.
I set up more reasonable cooldowns.
Okay, fair enough. I just had to let you know. Yeah, listen to me, Johnny. I will go straight to the cops with this one. I will go right to the bad cop. All right, cool. Muting again. Oh my god, guys, this is this is really fun. I'm super glad I'm doing this. Hopefully it's enjoyable for you guys. Damn right, Johnny. I will throw you under the bus. Surely look for trailheads as you read it in. I could do that. I could totally do that. Yeah, we can just do this. We can just make trailheads equal this, and then if char equals 0, then trailheads push. We're going to push into the trailheads array the key, because we know we found trailheads. So we can just do like echo found trailheads, and there we go. So now if we run this, found 9 trailheads. Does that sound right? Probably. What we can do is we can just grep for backtick 0 backtick, and we can do a nice little word count -l, and there are 9. So yeah, we found the correct amount. But you want the location too? Don't worry, I'm way ahead of you. Oh no, I'm not. I'm actually way behind you. I put key here, and I meant to put. No, I'm way ahead of you. I put key there. Don't try and trick me, okay? Don't make this take any longer, or else the people in your life will get upset that you spent so much time on Advent of Code. All right, we have this many trailheads, so now for trail head in trailheads, do done echo checking trailhead. Cool. Why did I do that? Cool. So now we'll go through and we'll check all those trailheads. So now that we have a location for the trailhead, we will do check for check path. I'm bad at naming. Check path, and we'll give it the trailhead coordinates. So we're going to make a function here called check path, and the goal of this function will be to, given a set of coordinates, look in all 4 cardinal directions, if possible, to find the next valid location. So not only do we need the trailhead, we need the starting number, because we're gonna have to call this recursively, right? I think we are. I think we're gonna have to call this recursively. Let me think about what data we want to pass here. I don't know if that makes sense what I'm thinking, but like we'll call check path with the trailhead location and give it a 0, so we know we're at number 0. So then we'll look at all 4 locations, and if there's a number 1 there, or 0 plus 1, then we will call check path on that location given the number 1. Then we will check that location given the number 2, and we'll keep doing that until we hit 9, which is our recursion stopping condition, and then we will just increment some global counter. Yeah. Let's do final score equals 0. We'll just have a running total of this. So let's do local number equals $1, local location equals $2. So what I mean by that is for here, instead of just giving it the trailhead location, we'll also give it the number 0. So we know that we have a 0, and we're looking for this. If number equal 9, then we know that we've made it to the end. I'm kind of jumping the gun here because it's a recursive function, so we're throwing this early, even though this would be the last thing that would happen. If number is equal to 9, then we are done. So we can just return after we increment the final score. So we are done. But if we're not there, if number is not equal to 9, then we have to check want number equals number plus 1. So if we're given number 1, we want to look for all the number 2s around us. Does that make sense? Local, let's see, x and y. And then we will read the location data. So our location data is stored in a variable that's separated by commas. So we can just do ifs equals comma, read the x and y coordinate, and then we can say at x comma y looking for number want num. That's what we'll do. So we can see if we're checking trailhead 2 comma 0, we're at 2 comma 0 looking for number 1. That makes perfect sense. We are getting there. Where do we look? Look in all 4 directions. So in order to get our new x and our new y, we'll do this. New x, new y. Let's get rid of this. Check south. In order to check south, y has to increment. So new x will equal x. New y will equal y plus 1. And then we'll run check path with the number that we are looking for, which is want num, and the location, which is new x comma new y. A lot of string manipulation here, but this is how we'll do it. And then we just need to do this 4 times. So check south. Instead, we'll check north, which is y minus 1. We have to do bounds checking, so we'll do that in a second. So hopefully this makes sense what I'm doing here. If we are checking east, then that means x is incremented by 1. And if we are checking west, that means that x is decremented by 1. We need to make sure that we are in bounds. Let's see. If x is less than 0 or x is greater than or equal to width, then return. There's nothing to do here. And we do the same thing. If y is less than 0 and y is greater than height, then we return here. Guys, I'm not even kidding when I say this. I think this is it. Like, I literally think this is all the logic we need. Well, we got something wrong because I kind of went into an infinite loop or we just stopped. Oh, no, I know what's happening here. I think I just called read, didn't I? No, never mind. I don't know what's happening here. Let's do a bash minus x on part 1, read in from example. Is it working? There's no way it would take this long, right? It could take this long. Did I increment the number? Want num is num plus 1. Let's do this. We're gonna put a stack trace here. Echo called check path with $1, $2. That's what we'll do. Yeah, if number equals 9, then we don't do anything. We just return from check path. Want num equals num plus 1. We read the x and y from location. If x is less than 0, we just do that. And then we call check path on want num with new x and new y. They're all declared local, so we shouldn't have problems with that because I have run into problems with that because I'm stupid. I can't see what's wrong with this logic. Let me think about this. It's possible it could take that long, but I don't think so. Let me try this. Oh, wait. Wait, what are we checking? What are we actually checking? We're not doing anything. We're just checking if number equals 9, if we made it to 9. How do we actually make it to 9? We didn't even look in the matrix. That's the problem. Yeah, let's see. If we get down here, our want number is num plus 1. But this is the number that we want. Yeah, we need to check if check what we have. So we'll have to do local have equals matrix at location. If num equal have, then keep going. Like that's our check. If it does not equal what we have, then we need to return. There's nothing to do here. I just didn't add this part. Cool. Yo, what's up, Aneurysm? Are you winning, son? We're going to find out. Bad Cop is really good at Bash. She's very smart, but she approaches it way differently than I do. I program it more like a C programmer. She knows a lot of really good Bash tricks and just like a lot of cool piping things and stuff that I am unaware of. I think I'm winning, though, because I think I actually just have the answer. If we print the final score, we get 81. And if we go over to the example, we have 36. So we're not winning. But that's pretty neat. Let's see. How did we get that many? That seems wrong. Let's see. Yeah, well, got 81, wanted 36. It's a minor difference. Like, listen, can't Advent of Code just be a little bit lenient if I give it kind of close? Like, they're both numbers. They're less than 100. Let's see. So we loop all the trailheads that we have, which are numbers that start at 0. We keep track of them at the beginning. And then we check path with a 0 at that location. So check path runs, and it has the given location, and it has the number 0. So the first thing we check, if the number is not equal to have, then we return. Yeah, so it should be equal because we gave it a 0 and there should be a thing at that location. If number is equal to 9, then we know that we made it to 9 and we can return the final score. Otherwise, we have to check in all of the things. Do you have to exclude already looked at spaces in the matrix? I don't think so. I thought trailheads can use the same numbers. They can overlap in the same numbers, right? Yeah. There's an example they give. There's an example they give here where 0 is up here and 0 is up here, but they both use these. So even though they both end at the same thing, yeah. Hello, this stream going to be a VOD after you're done streaming? Of course it is. I've started making all the VODs public, so they're all public, and I'll go through and edit these and make it a nice video. Is final score 9 times 9? It does look like it. Why am I getting that, huh? Do we always make it to 9? We shouldn't. But it does seem like it thinks every trail is valid. Yeah. Have 0, want 0. Have 8, want 1. Why are we not going in order? Oh, the wants should be in order. Yeah. What we have, I can't control that, but what we want is to have the next number in the thing. We want a 1, we have a 1. Cool. Now we want a 2, but we had a 4. We want a 2 at the other location, we have a 0. We want a 2 in the other cardinal location, we have a 2. We're not filtering out the location we came from, but that doesn't matter because if we make it there, we'll never come back because it's an incrementing number. Have blank want 9. Well, that seems problematic, doesn't it? What I probably should do in my scripts is I should start just like asserting certain things.
All right, I got part 1.
You're lying. You are lying.
I'm not lying.
Oh my god. Oh, I feel like I'm so close, but I do not have part 1. Oh no. Well, okay. Congratulations.
I mean, it's not over until, part 2 is the finish line.
No, I agree. I agree. And I was thinking about this earlier, like if we want to do like wait for the other person to do part 1 before we jump onto 2, but I think it's more fun to just No. I think it's more fun to just go ahead. Like you've already got part 1,
okay.
through part 2. Yeah.
How close are you feeling?
I'm feeling very, very close. I have a script that I think should work. So whatever I'm running into is going to be a very stupid mistake on my part. And I think I just encountered a variable I tried to print that doesn't exist. So like I literally think I'm so close.
So you have a script that prints out a number.
Yes.
I didn't have that until 20 seconds ago.
That's awesome. Now the number it prints out is 81, but
yeah, that's the wrong number.
Yeah, thank you. That's so
what is it supposed to be? 36?
Yeah, 36. Yeah. Yep. So 81 is wrong. Thank you.
You could try dividing it. No, that wouldn't work.
Well, I could try not getting 9 times 9 as 81. I could try doing that. Yeah. But yes, I would say keep going, crank through day 2, and I will catch up and I will destroy you in day 2, so don't worry about it.
Yeah, I believe. It's probably going to be impossible, so.
I know. I don't even want to read it. When you read it, don't tell me what it is. Don't even
Okay, I
don't want to know. All right, well, good luck.
You too.
Listening to both of you talk to each other is crazy. Listen, she just reached out a couple days ago. I had never even heard of her, but she reached out on email, and she was like, literally the email was, hey, I like Bash too. And I was like, all right, sick, we're going to be friends. So we read the X and the Y from the location. Oh, I see what we're doing. We're doing bounds checking on the numbers here. We're not doing bound check. No, that's fine. That's fine. Yeah. We got to do bounds checking earlier. We have to do bounds checking here. Let me think about this. We get the location, we break it into his XY coordinates. If this location is out of bounds, then we literally just need to break right away. There's nothing we can do. Then we need to check that location and make sure it's what we expect it to be. If it's not what we expect it to be, then we break out. If we're at 9, then we break out because our final score needs to be updated. So now that we made it down here, we need to check all 4 directions. And the way we do this, we figure out what number we want and all the possible locations that number could be in. Final score is 81. Okay. I've got both streams up, so it's like a ping pong delay. Yeah, I can't imagine doing that. Let's see here. Yeah, because we're getting 81. Why are we getting 81? What we can do here is we can exit after the first trail path, and we can see what's going on here. So our final score is 20 after the first one, and I don't think 20 can be formed out of this, can it? Oh, but once they get here... No, how... Wait. How would you ever get 20 out of a single trailhead? You would get 4. You would get between 0 and 4. And at that one that starts at the top, it's already out of bounds right away. Yeah, we should not be getting 20 there. How are we getting that? Echo inbounds x equals x y. Yep. What am I doing wrong here? The number that we have is in that location. If the number is not equal we want it to be, then we return. We do a y plus 1, a y minus 1, an x plus 1, and an x minus 1. These all look good to me. I don't want chat help, please. I mean, you guys can throw around like stupid little ideas, or if you see obvious bugs, but like, yeah, I don't want like any different like algorithms or anything. Yeah, that's just way too many, isn't it? No, it's just echo want, because it should just increment. Yeah, it's like we don't stop at the right spot. Yeah, it's like we're not stopping in the right spot. We're always just getting way too high. The algorithm seems like it's working, but we're just checking too many places. Yeah, it should all work. Yeah, the only time we check path is if we make it down here. So how are we making it down there? Zero, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9. How do we just find the right trailhead? I don't even think we should find the trailhead that fast. Because it's going to be all in different directions. You know what I mean? Darn, I was so ready for this algorithm. I was like, I know what I'm doing. Oh my god.
GG's.
Bro, you are lying to me. Are you really done?
Yeah. You are gonna like part 2. You're gonna like part 2, I think.
This is embarrassing. I am still stuck on part 1 with just some stupid issue, you know what I mean?
I would make like a, save your current state, just not to spoil part 2 or anything, but
Okay. Yeah, sure. Why? What's up?
You might have a part 2 solution currently.
I might have a part 2 solution. Okay, interesting.
The solution to the part 2 sample is 81.
No way. No way.
When I saw that, I was like, oh no, I'm in danger.
Part 1.safe. Okay, I'm literally CPing that script because like, what? Oh my god, this is wild. Oh my god. Well, okay, well, hold on. First of all, congratulations. Nicely done. Good race. You crushed me. That's amazing. Oh my god. You're allowed to relish in that. I don't mind.
I mean, I don't know. I did all of the days last year, so a lot of these are like kind of similar.
Okay, gotcha.
Like the thing you learn patterns of like, okay, this is how I'm gonna load a grid into memory and stuff.
Right. Yeah. I don't know how you solved it. I used a associative array with an x comma y coordinate.
Yeah, I do the exact same thing.
Okay. Yep. That's what I'm doing. I keep track of the width, I keep track of the height, and I kind of just loop over it that way. Although with this one, I actually just kept track of the trailheads when I first read the data, and I was like, oh, if it's 0, then I know it's a trailhead, so I might as well shove that in an array.
I have tried in the past to do like just use a regular array that's like one dimensional and then like do the math to index into it as if it was 2D.
Yep.
And it's not any faster. It's,
Really?
yeah,
That's
it's
weird that it's not.
at least not for like advent of code scale problems.
Oh man, it's so weird. I did that exact same solution. I wrote I don't know if I have it on my computer. I wrote 2048, that like game with the numbers and the grids or whatever. I wrote that in Bash like,
Really?
oh god, 10 years ago now. Yeah, but I did that exact
I'd love to
same
see
thing.
that.
Well, I mean, if you look at my stream, it's up right now.
Well,
But yeah, it's on my GitHub, and I wrote it all in Bash, and I did exactly that. I had a helper function to take a 2D set of coordinates and turn it into a one-dimensional set of coordinates and go vice versa. So it's all stored in a single array.
whoa, it's animated and everything.
Oh yeah, well I gave it the -A option for animation, so. And
That is nice.
It's incredibly slow. I rewrote it in C, and of course the C version's faster. But yeah, I wrote it in Bash first, and yeah, it's fun.
What are the inputs? Or is this the C one?
This is the Bash one. With
Oh,
Git
okay.
Remote show origin. Yeah, so it's on my GitHub, just as Bash 2048.
How do
the
you
input-
like? Is
I'll
it
show ya.
WASD or?
No, it's up, down, left, and right. Let me remember how I do
What?
it. I had to fork out to some external commands to make that work.
I was gonna say I've tried to do that and I don't.
Here's how you do it. You have to. No, I think there's more to it than that. But I do a read command with an SRN of a data size of 3. I chop off some parts of the data, and then you get these letters that signal up, down, left,
Wait, you
and
can
right.
just do it with read?
No, there was something else I had to set, and I'm gonna find it because I don't remember where it was. Oh wow, I used to use underscores everywhere. It's weird looking at your style from like 10 years ago. You might just be able to do read. I swear I used like a TTY command or something.
Oh, to like put it into
Like
maybe raw mode?
Yeah. But I can't find it, so maybe I didn't.
It would probably be what, like tput or something?
Yeah, I remember using tput or STTY. I think STTY has like cooked and raw mode as part of their commands, but it's been a million years. I don't see it in here. I actually may not have done that, to be honest. But then how would that work? If I do read srn3 like foo, and then I just press up. Oh yeah, I guess it just exits. And then I did foo and I chopped off the first 2 things. Oh yeah. Yeah. This totally works. So if you just chop off the first 2 characters or whatever those 3 characters are, and I press like left, I get D. And if I press right, I get C.
Why?
I can't tell you that
That's
this
so
is
weird.
portable. I can't tell you how reliable this is.
Yeah, I gotta read what the -S does.
Well, I think -S is just silent. Like it doesn't
Right.
prompt anything back to the user. Yeah, -S just makes it so it's silent, doesn't prompt anything back to the user. I am watching your stream. Do you not use the help command?
Ooh, that's the. I don't have it.
You most certainly have the help command. Help is built into Bash.
All right, I gotta switch to Bash.
You are in seashell traitor
I know.
to the cause.
Do you not echo input coming from a terminal? Oh, I didn't know it did that.
Oh yeah, because if I were to do like read foo, and then I start typing like hello, like when it prints the characters.
Oh,
as I'm
right,
typing
right,
them.
yeah.
Read -S would be good for like password, where I could say like hello, and it hides it until I print it. Oh man, now I'm so curious what I actually messed up and why I'm getting 81.
Oh, I see. Yeah, because they look like this. you
Yeah, yeah.
Yeah,
There you go.
that
Oh,
makes
I realized
sense.
my screen
I forgot
time
the
typing.
arrow keys are like weird escape sequences.
Yeah. And I'll tell you, probably like when I wrote this like 10 years ago, I had no idea what they meant. I was just like, like it's consistent, so that's good enough for me. Oh man, I really want to know how I'm getting 81. Maybe I'm just not reading the question properly.
That probably is it.
Yeah, the sum of the scores of all trailheads. The larger example has 9 trailheads. Yeah, I'm trying to figure out. Because when I when I run my code, it tells me that one of the trailheads has a score of 21. And I'm like, that's just, or 20. And it's like, that's just not even right.
I would specifically reread what the score is.
Yeah, 5, 6, 5, 3, 1, 3. Yeah, my whatever scores I get should be, I'm looking at the example, 5, 3, 6, 5. There should get no score higher than 6.
Or like what the
For one.
problem says the score
That's what I'm
is.
doing. Yeah,
You
yeah,
might
I'm
need to
looking at.
reread that part.
I might be doing something totally wrong here. Yeah. Oh man, please tell me I got messed up because I kind of like skimmed through it a little bit. Yeah. Hiking trails, any path that starts at 0, ends at 9, always increases by a height of exactly 1 at each step. They're never diagonal. Cool, cool, cool. Yep, the trailheads always start at 0. Cool. And it's 9 height positions reachable from the trailhead via hiking trail. In the above example, blah, 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 blah. So it has to go all the way from 0 to 9, and every time a trail can go to 0 to 9, it has a higher score. So if it goes to 0 to 9 5 times, it has a score of 5. I think I'm reading this right.
There's a part where it like has the score like highlighted.
Yeah. Yeah.
Describe, I think, is the part you're missing.
Oh no. The larger example has 9 trailheads. Considering the trailheads in reading order, they have scores of 5, 6, 5, 3, 1, 3, 5, 3, and 5. Adding these scores together, the sum of the scores of all trailheads is 36. No, I think that makes sense. Like,
You establish that a trailhead score is the number of 9 height positions reachable from the trailhead via a hiking trail.
yes. If I'm missing something, I don't know what it is. Because I think
It's that, yeah. This part I'll put in your chat.
Oh, okay, thank you.
That's the thing you're missing, I think.
You establish a trailhead score is the number of 9 height positions reachable from the trailhead
Oh god,
via a hiking
I'm getting
trail.
rated.
Oh no, sick. Heck yeah. Awesome. I'm gonna mute because she's muted as well. I still don't understand what I'm doing wrong. Like I swear that's my understanding of this. Trailhead score is the number of 9 height positions reachable from the trailhead via it. I don't understand. Yeah, that's what I'm doing. I'm not like frustrated with her. I'm just frustrated with myself. Like I don't understand what I'm doing wrong here. Because my check path logic takes a 0 trailhead location, and then we check it. And the way we check it is we break apart its XY coordinates. If they're out of bounds, then we're just done. We're done. There's nothing else to do. We check to see what character is at that location, and we assert that it's the character that's supposed to be at that location. And if it's not, then we return. We're done. There's nothing else to do. If number equals 9, meaning we have made it to the 9th location and we verified that we are at the 9th location, then we increment the final score and we return. There's nothing to do. We're done. Otherwise, now we have a number that's not what we want it to be. So the number that we're going to look for is whatever the current number is plus 1. And the new x and the new y are set to whatever the current x is with a y plus 1. Current x is with a y minus 1, x plus 1, and x minus 1. And we just check paths in all of those locations. If you reach the 9 through different trails, they don't count. I don't quite understand that. Okay. Okay. She's right. And I see what's going on here. Yeah, she's absolutely right. The part that she pasted is correct. I'm interpreting it wrong. It's not how many paths, it's how many 9s you can reach. The number of 9 height position reachable, not the number of paths. Yeah, so we have to keep track of the trailhead number. What do we have to keep track of? Because it's per trailhead. Don't worry, a number of people have misinterpreted the problem. That is good. Okay, I completely get how to do this now. Here's what we're going to do. I'll pull up the terminal. Declare -a 9s. So an associative array of our 9s, and we will keep track of all the positions of 9s that we've encountered. But after we're done checking a trailhead, we are going to clear it out and we're going to remake it. Because each trailhead has to go to a specific 9. This is what we're going to do. So here's how many 9s we can encounter. If number equals 9, and -z 9's location, then we'll increment the final score and we'll set 9's location to 1. And this will filter it out. Final score is 5, which is correct for that one. It's because I just have an exit here and I need to move this down here. Thank you everyone in the chat. Yeah. And thank you. I know Bad Cop can't hear me, but she was absolutely right to point that out. I just could not see it. Final score is 36. Yep. So if we give it the real input, the final score is 468. That's the right answer. You are 1 gold star closer to finding the chief historian. We did it. Part 1 down. It's funny. I'm a little bit bummed that I'm not bummed that I lost to Bad Cop. It's a friendly competition. I think that's awesome. I'm just glad we're collaborating. It's super fun. She seems super cool. I'm just bummed that I read it wrong. Some of these problems come down to me reading it wrong. And if you watch, I kind of skimmed through the question at the beginning because it was a race and I wanted to go fast. I should have not done that. I shouldn't have skimmed it. That was my mistake. Let's look at part 2. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes, and finally returning. The paper describes a second way to measure a trailhead, called its rating. A trailhead's rating is the number of distinct hiking trails which begin the trailhead, for example. Okay. The above map has a single trailhead. Its rating is 3 because there are exactly 3 distinct hiking trails which begin at the position, but they all lead to the same 9. So I think Bad Cop is right. I think I got the right answer here. I think I already had the algorithm working. You got to be kidding me. Here's a map containing a single trailhead with a rating of 13. Okay, I don't feel like doing this right now. I mean, like, I don't feel like verifying this, but yeah, I think we're on to it. What just happened there? Why did that window get so small? There we go. That's good enough. Okay. Considering the trailheads in reading order, they have a ratings of 81. Yeah, okay. Well, let's go back to the terminal. And thank God she told me to save it because we have part 1 safe. Let's CP part 1 safe to part 2. Let's run part 2 against our example input, and we get not right. I must just be printing the wrong thing. Where am I exiting? Final score is 81. Final score is 966. That's the right answer. What I had for part 1 was the right answer for part 2. But because I glossed over and read it slowly, I didn't quite get there. Really cool. Thank you, Bad Cop, for telling me to save that. Oh, that's so funny. That is... I don't know if she's still being raided. I can talk to her, but I gotta walk around for a second. Whew. Oh, I don't even feel dumb. That's not what I feel like. I just feel like I tried to optimize for being fast and it didn't quite work. Oh, yep, she's back. Hello. Yes, thank you. Thank you for telling me to save part 1, what I had, because it just literally worked. I had to remove some debug statements, but yeah, it just worked.
Yeah, I watched. I really think it's weird that the part 1 was the part 1 and not the other. Like, it should have been flipped.
I would have reversed it, because in my mind, like, having
it's so weird that you have to delete code to
like we're literally removing a filter. Like, I had to add a filter for part 1 and then remove it for part 2. Kind of cool. It keeps you on your toes, I guess, but it's not what I expected. Oh my god.
Yeah, that was a weird one.
Dude, I know you were getting rated, but like when I reread the problem and I reread your what you had quoted to me, I was like, oh, you're right.
It's the tricky wording. It's that Eric guy. The problems do say the right thing. It's just sometimes it takes like multiple tries to figure out exactly what it's trying to tell you.
Yep. And it's frustrating too, because like you said, like, the problems are very explicit, very specific, and they've been completely right in all of my experiences. So any problems are like, oh, I brought in my own assumption or something.
Yeah.
Real quick though, before we go on, someone in my chat says it'd be fun if we reviewed each other's code or compared our answers or something.
Yeah, we could do that real quick. Did you push yours?
Yes, I pushed mine to GitHub. I assume you did as well?
Yes.
Okay.
I forgot what your GitHub handle is.
Bahamas 10. And don't ask.
Bahamas? Okay.
Yeah, I can type it into the chat if you need it.
No, I got it.
Okay, picture of me.
It was in my history. I just didn't remember.
Heck yeah.
J10, let's see. What did you do? I'm gonna guess our answers or our solutions are pretty similar here. Actually,
I'll pull up your stream and we can watch you review.
Yeah, let me go to a better layout for this. Is there a way to make this part of the page not? Hold on. Delete element. There we go.
See, we both named our repos Advent of Code, so I'll just look at it.
All right, so you made matrix. You got height and width.
Mm-hmm.
Trailheads is regular array. I think I literally have the same thing, except I did dash lowercase a.
Amazing.
Oh, and you read line by line. I read character by character.
So you're doing like a read N1 or whatever?
Yeah.
Okay.
Okay, reading in looks fine. And then, okay, this is something that I've noticed that you do, and it's, I don't know how I feel about the dash in the function name.
Okay. I understand why you might be against it, but yeah, I don't know. It works.
I mean, I think I'm only against it because I literally didn't know you could do it until.
Yeah,
but it makes sense because I have like scripts that have dashes in the name, so I don't know why you wouldn't be able to do it with.
Exactly. And I think when it comes to a command on an operating system, you can use any character you want as the file name as long as it doesn't have a slash or a null byte.
Yeah, I think you can use some pretty disgusting characters in function names as well.
Oh yeah. But yeah, I got used to the dash. I've seen some people write code where they like fake classes. They have like module : the name of the function. It's like, it's just a name at the end of the day. But yeah, it's wild.
I've seen that too. I don't know what you expected to happen when you redeem sand while I'm on GitHub, but
what does sand do?
It's the thing that makes all the code fall down.
Wait a minute. Is it a Tmux, like Tmux sand?
Yeah, it does this. It doesn't look so good on that one, but
I've seen this. I've seen this on Twitter, and I saw this on
you,
GitHub, and
you
I looked
saw
at
it
the
on
project.
Twitter because I did that.
I didn't realize that was you. That's so awesome. Oh, that's so cool. Oh my god, that's cool. So I was familiar with your work before I even knew it. That's so funny. Wow, that's awesome. Oh, but yes, feel free to critique my code, whatever you have to say or whatever you want to see. I think it's pretty straightforward.
Yeah, I like this. I didn't think of using IFS as the comma. That's smart. I always do this goofy thing. I mean, you're gonna look at my code in a second, so I'll just wait.
Okay.
Yeah, your conditions and stuff are way nicer than mine.
I am a C programmer at heart, so I approach pretty much every language like it's C. So it's gonna have a very specific like Kernighan and Ritchie style.
I just always forget that you can do like the math expressions as conditions. Yeah, I always do the
Yes,
square
so
bracket
good.
ones.
It's so good. I love it. You don't need the dollar signs for the variable names. It's very clean.
I like dash Z. It's classic.
Yeah, that was I had to pull in at the 11th hour. That's where I checked if we had already been to that trail ending before.
All right. So how are you looking? Oh, you're doing DFS. Okay. So you recurse down,
Yep.
and then
I was originally going to make my own like stack variable, which would just be an array that I would like push work into and then pop off. But I was like, it's only like 9 stops, so like I'm not going to recurse too far in.
yeah. And then this is how you're doing the whatchamacallit?
Keeping track
Keeping
of
track
if
of yeah, if you've been there or not.
So that's why it
Yeah, that
doesn't
makes
look
sense.
as clean as the rest of the code, because I like unset it, then redeclare it. That was just like the last minute I threw that in.
I think the only real difference between ours is you did DFS and it's more readable.
Ooh, what a compliment.
Yeah. Feel free. Have you looked at mine yet? Oh, yeah.
Nope, I'm going to look at it right now.
All right.
All right.
I'll pull up your stream.
Sweet. I will share my terminal. I already checked out your code. So here is what Bad Cop had. Let's take a look at this. So, you take the file.
Oh,
as
no,
an
I'm covering you
argument.
up.
Cringe. You don't just read it from standard in. It's just like your face is just where mine is. That's awesome. This is a Bad
Oh,
Cop
yeah.
stream now.
Taking the file as an argument is part of my
Your start script, right?
shenanigans. Yeah. I have a test runner that every time I save, it will rerun the program. And the thing that's over engineered that I did that's new this year is if it gets the right answer for the sample, it'll automatically switch over to running it on the real input. And then if it gets an answer using the real input, it puts it on my clipboard.
Oh, that's cool. That's so incredibly over-engineered.
Yeah. I thought I was gonna go for leaderboard on the early days, but I didn't.
Yeah.
I didn't even get close.
Nah, that's so cool though. All right, so let's take a look at what you have. We have the file here, x and y equals 0. You make a grid and you make a trailheads. Wow. Okay, so we're off to the exact same start here. Yep.
Yeah.
Yeah. Wow. Okay, so you read a character by character, which means you have to use this to detect when you have a new line. Yep. Okay, makes sense. Every time you get your new line, you increment the y, you reset the x. Makes sense. We move on. When you're down here, you check if it's a trailhead, you store it. Otherwise, you just store it in the grid. This is like identical. Like we do the exact same thing here. Okay, cool. And then you do, okay, look at this, your breadth first search here. Okay. That is literally going to be a difference. I won't look at this function yet. Let's scroll down. For trailhead and trailheads, you do a breadth first search, and then you pipe it to paste, and then you pipe it to BC. This is a common thing I see you use. And if I'm not mistaken, you just output a bunch of numbers, you put plus signs at the end of them, and then you run it through BC to actually just create the sum.
Yeah.
Cool. So this makes perfect sense. So then if I'm right here, you should probably just output like a 1 or whatever the count is for the trailhead. But let's not spoil. Let's take a look. Yeah. So you queue up what's in $1. What do we put in here? Oh, the trailhead coordinates. Okay, cool. You keep track of your visited, count is 0.
So the Q1 is like doing a pop. It's taking a slice of everything but the first element.
Yes. Okay. I see that here. Yep. So you pop that off. Oh, and this is what you do to get your left side and right side of the comma. Okay, yeah, I just use the read.
Read is way smarter. I don't know why I didn't think of read. I just got so used to doing it this way.
Also, 2 spaces for indenting. Wild. Let's see. Okay, cool. Oh yeah, and then ooh yeah, this is a nice, real simple notation just to chop off the first element there. If you've already visited, you just try again. Okay, that makes sense. Otherwise, you store it as visited. You check if the character's there. If it's equal to 9, you're done, and then you loop again. Wow. Okay, yeah, it's like exact same lot. Yeah, this is identical. Yeah, you just traverse into it differently, but this is wow. Darn, I wish I had read the problem properly.
Yeah, the only thing I changed was like deleting those 2 lines with the visited for part 2.
Yeah. Yeah, so you do exactly, yep. Oh yeah, once you start doing number stuff, you might approach this differently, because like I would totally just like grid $A equal C+1. Like you can just do that. It just looks, in my opinion, so clear.
Wait.
This works.
You would need the $A though, right? Because if you just did A, it would try to.
Yes. For this one specifically, you need the $A because it's an associative array, right?
Yeah. Otherwise, it would try to.
Yep. And then you would just get probably 0 out of it, and it would cause you to waste a whole bunch of time on like day 4, like I did. So, so don't do that. God, that was a nightmare. Yeah. Okay. Wow. We basically had like very, very similar logic. You just nailed it out faster than I did. Nice job. And then this should be almost identical if I had to imagine. Yeah, it's like there's less logic in this. Literally less logic. Yeah, okay. You literally comment lines.
I commented on my, yeah.
Yeah, okay.
That's the only difference.
Perfect. Beautiful. Awesome. Well, nicely done and good job. Congratulations on your victory on day 10.